Dear students, now we are going to discuss about sample matrix inversion. So this is also one of the techniques in the adaptive beamforming. So now see here the sample matrix inversion. It is a direct implementation of Wiener solution using an estimated covariance matrix from finite data samples. So already we have discussed about the correlation matrix, the same method only here also. But here we are using the Wiener solution to implement this sample matrix inversion. So what we have do here means that SMA beamformer that we already discussed, no, that correlation matrix. So other than that, here we are replacing with sample covariance matrix. So it yielding a practical implementation of optimal beamformers such as Wiener or the Kaplan beamformers. Now see here, so this is the procedure for sample matrix inversion. The first thing we need to collect the data snapshots. So like x of 1, x of 2 up to x of n, and you have to estimate the covariance matrix. So for that what you have to do means r power r vector is equal to 1 by n, summation of n is equal to 1 to n, x of n, x Hermitian of n. So these things also already we have discussed in our correlation matrices. The same thing only here also we are using. And the second thing what you have to do means you have to invert this covariance matrix. The next thing what you have to do, we need to find the weight vector. So how to compute this weight vector means using of Wiener method or Kaplan method. Kaplan method already we have discussed, that MEDR method, minimum variance distortionless formula. So through that we can easily compute the weight vector. The next thing is you have to apply the beamformer. So that is your final output of signal. For that what you have to do, for the weight you need to take Hermitian of your weight vector, and the next thing you have to multiply by the x of n. So these are the procedures involving in sample matrix inversion. The first thing, collect data snaps. Second thing, estimate covariance matrix. Third thing is invert covariance matrix. And the fourth thing, compute weight vector. And the fifth thing is apply beamformer. So now see here that sample matrix inversion for Wiener beamforming. So here you need to find first the minimized mean square error. For that the J function you are calculated. For that the desired signal minus that WH into X of n. That function you have to modulus and the square. And what is your Wiener solution means you have to take the inverse of your that covariance matrix with P. So where the P value is nothing but that ensemble of x of n into d conjugate of n. So where you have to approximate that value means you have to take that r inverse into p. So now the p vector finally we are taken as 1 by n summation of n is equal to n x of n d conjugate of n. So like that only you have to find this beamforming. So this is the SMA weight updating algorithm. See that antenna multiple input you are taken. So the weight vector you are taken. So normally these types of techniques depend on the application we can select. So previously we have discussed about LMS algorithm. So there also the structure is same, but the technique you have to modify. So here we are using this algorithm. That means this formula, that Wiener solution, the same procedure we are following, that collect data snaps, estimate covariance matrix and invert covariance matrix, so like that. Now the next thing is, so this is the real time application of this sample matrix inversion. See the antenna elements we have to take. So in that beamforming network we need to, based on your antenna element, you have to adjust the weight by using of Wiener solutions. And what are the application of the sample matrix inversion means? The first thing is radar and sonar systems. So actually these radar systems and sonar systems, it will be effectively enhances the desired signal by using of adaptive beamforming. In that adaptive beamforming, that one of the main technique is sample matrix inversion. The second thing is smart antenna. The third thing is direction of arrival for estimate the pre-processing technique, and finally we are using for wireless base station. So these are the common application of sample matrix inversion. Thank you.